Jai Hind students. So we have discussed 5 cases of propagation of error. There is still one case left, and that case is when the result involves the product of the powers of maybe 2-3 measured quantities. Like, let's deal with this case: a to the power n, b to the power n divided by c to the power n. Suppose the result involves the product of the powers of these 3 measured quantities a, b and c. Right? We'll proceed exactly the same way as was done in the previous 5 articles. So what we'll do is, let del x be the absolute error in the measurement of the result, that is x. Let del a, del b and del c be the absolute errors in the measurement of a, b and c respectively. So you must remember, what's the second step? We need to write equation 1 in terms of their absolute errors. So x in terms of absolute error would be written as x plus minus del x, isn't it? A in terms of absolute error would be written as a plus minus del a. B in terms of absolute error may be written as b plus minus del b. And c, it may be written as c plus minus del c. Look students, the articles which we are trying to derive over here can be also obtained by calculus method as well. But I am avoiding that method because so far you are not aware of calculus method, right? So for that you need to be aware of differential calculus. Then only you can proceed with the alternative method of finding the conclusion. Here we are making use of the normal method just by using binomial expansion. So let's try. A can be taken as common, a to the power m. So what is left is 1 plus minus del a by a to the power m, to the power n. Over here b to the power n can be taken as common. So the term left would be 1 plus minus del b by b to the power n. Over here c to the power l can be taken as common. So we will be left with 1 plus minus del c by c to the power l, isn't it? So it can be modified, x plus minus del x. It can be written as a to the power n, b to the power n divided by c to the power n. And the terms left would be 1 plus del a by a to the power m, 1 plus minus del b by b to the power n, and this term, it will become 1 plus minus del c by c to the power minus l. Clear students? These are simple mathematical steps. You need to keep on proceeding. So this term, it is equal to x. So it can be written as x plus minus del x by x. We can write it like this, right? And these terms can be expanded binomially. I have told you numerous times. 1 plus x to the power m is equal to 1 plus mx, where mod of x is less than 1. So only the first 2 terms are used because the terms containing higher powers of x are very small and hence can be neglected, right? So let's expand it binomially. This term del a by a, which over here is x, is less than 1. So it can be expanded binomially. So what do you get? 1 plus minus m del a by a. The terms containing higher powers of del a by a are neglected. So we'll write only the first 2 terms. Over here, expanding using binomial theorem, what do you get? 1 plus minus n del b by b. And in the third case, again using the binomial theorem, what do you get? 1 minus plus minus minus is plus l del c by c. Clear? So it will be 1 plus minus del x by x is equal to, let's first solve these 2 terms. So opening the bracket, what do you get? 1 plus minus m del a by a plus minus n del b by b, and then plus 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 minus plus plus. So what do you get? Plus m multiplied by n del a del b divided by ab. and this term, which is 1 minus plus L del C by C. Clear? So students, I have already stated del A, del B, del C, they are very, very small. So the product of these small terms, del A into del B, or del A into del B into del C, or del B into del C, the product of two small quantities would be still smaller. And logically they can be avoided. So this term can be easily neglected. This term approaches to 0 and this term can be neglected. So we are left with these two terms, right? So let's solve it. So what we get is 1 plus minus del x by x. It will give us 1 plus minus n del a by a plus minus n del b by b multiplied by this term 1 minus plus L del C by C. Now let's open the bracket and let's solve it. So what you get is 1 plus minus del x by x is equal to, right? Let's solve these two terms. 1 plus minus m del a by a, this multiplied by this 1 would be plus minus n del b by b. This term when multiplied by 1, it will give us minus plus L del C by C. There will be other terms as well. There will be other terms as well. On solving, you will get this multiplied by this term. But here it will involve del A into del C. Again, it will be very, very small, so it can be neglected. Then another term involved would be n del B by B multiplied by L del C by C. So del B del C, again, product of two small quantities. So it can be again neglected. This being still smaller and approaching to 0 can be neglected. So all those terms involving product of two small quantities can be neglected. So we'll be left with only this term, right? 1 get cancelled. So we get this. Okay. Now as you remember, there are various combinations, right? But while dealing with errors, we always take maximum permissible error. So taking maximum permissible error, what we get is, this is the absolute error in x, right? Maximum absolute error in the result. It is equal to power times a to the power m. So whatever is the power to this measured quantity a, that m times the maximum relative error in a plus n times n is the power of b, the maximum relative error in b plus l times the maximum relative error in c. So this is the conclusion. Now you can express the above result also in terms of percentage error. Look students, multiplying both the sides by 100, you can express the above result in terms of percentage error as well. That will give us maximum percentage error in x. It will be equal to n times the maximum percentage error in a plus n times maximum percentage error in b plus L times maximum percentage error in C, right? Simply we have to multiply 100 on both sides. So that will give us the result in terms of percentage error as well, right? So let's discuss a numerical based on this, right? So let us consider a quantity is given by a cube square root of b divided by c d to the power 3 by 2. Suppose a physical quantity x is given to be a cube root b divided by c into d to the power 3 by 2. A, b, c, d, these all are the measured values. X is the result. And it is given that the percentage error in a, b, c and d are respectively 1%, 2%, 3%, and 2%. This is the percent error in the measurement of A, this is the percent error in the measurement of B, this is the percent error in the measurement of C, and this is the percent error in the measurement of D. So what is the percentage error in the measurement of X? Percentage error in the measurement of X. This is to be found. Right? So again I repeat my question. It's an interesting one. Just we have to make use of that result. A physical quantity X is given by A cube root B divided by C into D to the power 3 by 2. And it is given that the percentage error while measuring A, B, C and D are respectively 1%, 2%, 3% and 2%. You are supposed to determine the percentage error in the measurement of X. So how to proceed? It relates to the article which we have just now done. Right? So errors are propagated in that particular manner. And I have told you, if you multiply by 100, that will give the result in terms of percentage error. Right? So let's write this. So del x by x multiplied by 100. This is the maximum percent error in the result. Now what is the power of A? It is 3. So 3 times maximum percent error in A, that is del A by A multiplied by 100. Plus what is the power of B? Square root means B to the power half. It can also be written in this particular manner. It can also be written in this particular manner. So the power of B is half. So half times the maximum percent error in B, del B by B multiplied by 100. Plus what is the power of C? That is 1. So it will be 1 maximum percent error in C, that is del C over C multiplied by 100. Plus what is the power of this measured quantity D? It is 3 by 2. So 3 by 2 times the maximum percent error in D, that is del D over D multiplied by 100. Clear? This is what we have obtained. This is how the errors are propagated in this case, isn't it? So we have made use of the same conclusion, right? Let's substitute the value. Del x over x multiplied by 100, it would be equal to 3. This is the percent error in the measurement of A, which is given to be 1%. This is the percent error in the measurement of B, which is given to be 2%. One time, percent error in the measurement of C, it is 3%. Remember, only positive sign is to be considered because we always consider maximum permissible error. While measuring error, we always try to calculate the maximum error. Right? Maximum uncertainty in the measurement of the result. So, plus 3 by 2, this is the maximum percent error in the measurement of D, that is 2%. So, we can easily solve it. 3% plus 1% plus 3% plus 3%. 10%. This is the answer. So, the maximum percentage error in the measurement of X in this case would be 10%. So students, this is how such numericals can be easily solved. These are very, very simple and interesting questions. Practice more and more such numericals and you will feel confident. Okay. Why not discuss some other question as well? Let's do it. Suppose a square plate is given. This is a square plate. This is a square plate, right? Of side A. And some forces applied over here. Some forces applied over here. Right? Now my question is the side of this square plate is measured to be, suppose, 10 plus minus 0.1 meter, right? And let us consider the force which is acting on the square plate in a normal direction, perpendicular to the area. It is given by, suppose it is given by 1000 plus minus 1 Newton. Right? Find out the pressure exerted by this force. Find out the pressure. And we need to express the result. We need to express pressure both in terms of absolute error as well as in terms of percentage error. So students, let's do it. Now for that I have told you how to proceed. True value is to be dealt separately while the errors are to be dealt separately. Now you need to find a formula between these three. What's the relationship between pressure, force and area? We know that pressure is equal to force per unit area. Here area is not given, but area of a square plate is side square. This is the formula. So P is equal to F divided by what is side A, that is A square. Am I clear, students? This is the formula. Pressure is equal to force divided by area. Area is square of the side. In this case, the area under consideration is of square shape. Now look, this is the result involving the power of some measured quantities. So its power is 1 and the power of side is 2. So how the errors will be propagated? So it will be del P by P. Maximum relative error in the pressure, it will be equal to 1 time maximum relative error in force plus 2 times maximum relative error in side. Is it clear, students? So we have to deal separately. True value and errors, they have to be dealt separately. Let's find out the true value. What is force? It's 1000. This is the true value of force and this is the true value of side. Side is 10 square. So pressure is 1000 divided by 100. So it will be 10 Newton per meter square. That's the SI unit of pressure. It is so known as Pascal. Let's find this. So del P over P is 10. True value of pressure is 10. It will be equal to 1 time. What is del F? What is the absolute error in force? It is 1. Force, it is 1000. Plus 2 times. What is del A? Absolute error in the measurement of side. That is 0.1 divided by true value is 10. Right? Let's solve it. Del P by 10 is equal to 1 by 1000 plus 2 by 100. So it may also be written as del P is equal to 1 by 100 plus 2 by 10. So del P may be written as 100 can be taken as LCM. 1 plus 10, 10, so 20. So del P would be equal to 21 by 100, which will be equal to 0.21. 0.21. Right? So, how the pressure can be expressed in terms of absolute error? It can be written as 10 plus minus 0.21 Newton per meter square. This is how the result can be expressed in terms of percentage error, right? In terms of absolute error. Now, in case you wish to find percentage error, percentage error is simply absolute value divided by true value multiplied by 100. So what you get is del P, it is 0.21. P, it is 10 multiplied by 100. So it will be 2.1%. It will be 2.1%. So pressure in terms of percent error may be written as 10 plus minus 2.1%. I hope these illustrations are very important in order to clear the theoretical concepts. So students, always remember, whenever you do some theoretical concept, do practice numericals based on that. That will enhance your application skill basically. Right? So, this was another formula related to the sixth case. Right? So, let me recapitulate all the topics. Right? The 6 cases which we have discussed, we can easily recapitulate all the 6 cases, starting from addition, subtraction, product, quotient, and then power. So, what was the first case? When the result involves the addition. Second case, when the result involves the subtraction or the difference of two measured quantities. In both the cases, the errors are propagated in the same manner. That is, maximum absolute error in x is given by sum of the maximum absolute error in the observed values. Right? This is the way in which the errors are propagated. Third, when it involves product, and fourth, when it involves quotient. In both cases, again, the errors are propagated in the same manner. So it is del x by x, it will be equal to del a by a plus del b by b. On multiplying both the sides by 100, you can write it in terms of percentage error, right? Fifth, if it's in this form, then del x over x is given by power times, here power is m, so m times maximum relative error in A. Right? Sixth, if it is given by a to the power n, b to the power n, c to the power n, then the result obtained is maximum relative error in the result is equal to m times the maximum relative error in A plus n times maximum relative error in B plus L times maximum relative error in C. So this is how the errors are propagated in these 6 cases. So students, I hope these all topics are very clear to you all, right? So we'll conclude this session and hopefully you'll come fully prepared in the next lecture, right? Thank you.